Okay, come. Children, the time now is 7:32. Sorry, I used 2 minutes to try to share certain things. Okay. Today we are doing set notation again, set language and notation. All right. And today we will finish this topic. All right. Some of your teacher maybe even started on statistics already. Some of the school quite kiasu one. All right. And I also know that some of the school, right, they actually did set notation in the November, December period. All right. So when they start off the new subject, right, or the new topic, right, they start off with statistics. Some even don't start off with statistics. Some even go straight into probability. All right. So I understand that you are from different school. All right. You also need to understand that because there are other students following the textbook also. And the textbook, right? The first topic is set notation. So regardless what, we still have to finish our set notation. Today is our last lesson for set notation. Next week we are going into statistics. So there will be about 2 to 3 lessons about statistics. Then immediately we'll go into probability already. All right. So my aim, my target is to finish the entire 6 topics of your Sec 4. All right, by March or by April. All right, we have to finish by then. All right, because the last 2 topics is matrices and vectors. Especially vectors, it can be a little bit heavy. All right, so I need time to do some revision, right? Because vectors, it actually links to something called coordinate geometry. It also links to something called similar triangle, right? So if your these 2 topic, coordinate geometry and similar triangle, is strong, then we will have an easy time, all right, when we do vectors, all right? But let's not talk about it too far. Let's do the now thing. Now thing is about what? It's about set notation and um, set language. All right, so let's try to finish off with today's lesson. All right, talking about things like Venn diagram, intersect, and union. All right, again, as I say from last week, right, this topic is not difficult. This topic is not difficult, it's just irritating. All right, this topic is not difficult, it is just irritating. So last week, right, we talked about this. Can you see or not? Beautiful, right? I know, I know. All right, we talked about the thing like proper subset and the subset. Yep. And I told you when to use the proper subset and subset. All right. So for the word subset, right, you can you can break it down. For example, this example, 2, 4, and 6. All right. You can break it down that 2, all right, races 2 is a subset of 2, 4, and 6. All right. You can write out the different permutation. All right. Then the exact thing, 2, 4, and 6, right, is considered a subset of A. Subset means what? The one with the extra equal sign below. Right? So down here, this example will give you 8 different subsets. But the meaning of proper subset means what? The exactly the same, the 2, 4, 6, this one. You see the mouse down here? Right, this is not counted. This is the only one that's not counted. Right? So the extra equal sign means that what? Is exactly the same. All right? Then you can put an equal sign. Can? Then I make a little mistake of the n, right? Remember the n? All right, the n means like how many. It's not how many subset here. It's like how many members, how many elements inside the particular set. All right, so this is what we did last week. Okay, so today, right, today we are basically going into something called the Venn diagram. Right, so maybe you can you can um you can draw a Venn diagram for me. All right, a Venn diagram, how does it look like? So a Venn diagram is actually made up of circles, all right, and rectangle. All right, Venn diagram. It's very simple. Don't worry about it. All right, and we'll be using 2 things very common thing, which is called a union. All right, these 2 very common symbol, union and the intersect. Okay, very often. All right, union means what? Remember, it means everything. Okay, and intersect. All right, intersect means what? Overlap. Remember this? Right, so these are the 2 symbols that we will always use. And not only that, we also use something called the what? The complement. So for example, A complement. Right, so this one on top, right? This one on top. Right, some people call it complement. Some of it call it a prime. So we call it A prime. For me, right, I will call this what? I will just call this not A. Not A. Okay, so you'll be using a lot of all these things for this Venn diagram thing. All right, so very, very, very simple. Don't worry. All right, just a quick one example. So for example, they say that this symbol here, oh, this is called the what? Oh, you all know this as what? Universal set. All right, this is called a universal set. All right, to me, it's called a boundary. All right, to me, it's called a boundary. So for example, the universal set is made up of the alphabet A, B, C, D, E, F, G. All right. Universal set is made up of the alphabets A, B, C, D, E, F, G. And they say that A is actually a set of what? A set of elements inside being A, D, and F. All right. Then they also say that there's a B. B consists of the elements of, let's say, B, D, E, F. All right. Okay, so these are the information that's given to you. And from here, they ask you to say, hey, I want you to draw a what? A Venn diagram from here. All right. So this universal set thing, right? This universal set thing. Okay, this purple universal set thing. It actually represents the rectangle. All right, it actually represents the rectangle. Okay, it represents the rectangle. It represents the boundary. So everything must happen inside this rectangular box. All right, that's why I wish call it as a boundary. The next check, right? You have to check for me. All right, the next check you need to check for me is what? Is whether the A and the B, right? Do they have anything in common? Oh yes, right. They have D and D in common. Oh, they got F and F in common. Got common. All right. So D and F are common. D and F are common. Common means what? Common means they are appearing in A and in B, right? So there is some intersection happening. So if there's some intersection happening, right, you draw A as a circle like that. Just sketch. And B as a circle whereby they intersect at a little portion. So this is your A circle and this is your B set actually. And can you see now where do they intersect? They intersect at this particular place, right? The center portion here. Can you see now? So this portion here, right, is either A or it can be B, right? It can be set A or set B. So your D and F, right, because it appears in A and B, right, you can write the D and F here. Can you see? So for set A, there's A, D, and A, F, right? There's the alphabet A. Where do you put the A? Right, the A, you have to put it down here, right? So if you just look at this blue circle, just look at this light blue circle, can you see now? A, D, and F is still inside A, right? It's correct. Okay, now you look at the dark blue circle. Look at the dark blue circle. All right, this dark blue circle must have what? Things like B, D, E, F. B, D, E, F. B, D, E, F. Right, so inside here, can you see that? It really has B, D, E, F, right? So, okay. And the D and F thing is overlapping. Okay, so children, the boundary, the boundary is talking about what? Everything, So we have A, B, C, D, E, F, G, Look, you must check. We have A, B. Oh, C is missing. We have D, E. We have F, we have G is missing. So C and G is missing. C and G is missing. How? It must be inside the rectangular box, but it is not inside A or B. So your C can put down here, and your G can put down here. Ta-da! So do a check. A, B, C, D, E, F, G. Everything is inside already. Good job. You see? Right, so that is how you draw your Venn diagram. Right, so this is the part whereby they intersect one. Right. So can it have a situation whereby there is no intersection? Yes. So for example, if you have let's say a C, let's say C. Right. C is let's say C is maybe B, C, E, maybe. All right. Maybe we have a set C. There is B, C, E. And the question asked me to draw A and C. Oh my goodness. All right. The question asked me to draw A and C. So again, you come up with a rectangular box. This rectangular box is your boundary. All right. It's your boundary or your universal set. All right. And you're supposed to draw A and C, right? But look at A. A is ADF. C is BCE. Oh, never intersect at all. Never. No intersection. So this is your A. And this is your C. Never intersect. They are disjoint. They are disjoint. So down here you can write your B, C, E. And down here you can write your ADF. Is that okay? So they are separated one. Possible? Possible? Yes. Can be. Can? Okay. Or they can come up with another situation. Maybe we have a D. All right, D. D consists of let's say CE. Oh yeah? Oh yeah? Can you see not? All right, and now the question wants you to draw what? Now the question wants you to draw CE, CD. All right. So you draw a rectangular box again. This is a universal set. All right. Can you see that C and D? Hey, sure. The entire of D, CE is inside C, right? Oh yeah. So the entire of D is inside C. So this is C. The entire of D is inside. Yeah, down here. So down here is C and E. And C itself, right, got BCE, right? So the B must put down here. Right. Okay, then of course, right, you are supposed to put in the rest of the boundaries. Right. So for example, the AC down here, what is missing? A, B, C, D, E, F, G. G must put down here. How about this one? Right, this one is a C, B, E down here, right? A is missing. A, B, C, D, E, F, G outside. Can you see? So there can only be three situations. Situation number one, they overlap a little bit. Situation number two, they are totally never touch each other. Situation number three, they are one inside another one. Can you see not? So these are the only three situations that can occur. Okay? So you must be able to see, right, by looking at the alphabets or the elements, whether got anything in common or not. Right, so these are what I call Venn diagrams. Right? It's ultimately about circles and rectangle. Okay? Then slowly they will ask you question. Hey, they will ask you, hey, for example, this one, part one. They'll ask you, hey, what is A intersect B prime? Huh? Right, you're supposed to list out the elements of A intersect B prime. What? All right. Don't worry. You do the what? Bracket inside first. It's just like primary 5. You learn the 4 operations. You're supposed to do the bracket first. Where is A intersect B? A intersect B is down here. Can you see not? Which is DF. That's A intersect B. But what is this prime? Prime means what? What is this complement? It means what? Not. So it's not. They say they want not DF. They don't want this intersection. They don't want. So it's not DF means what? It's everything else. All right. So not DF, it means it's everything else, which is A, B, C, E, G. Can you see not? Children, can you understand not? All right, because A intersect B is DF what? DF, look at this one. A intersect B is DF. But they're saying not, I don't want A intersect B. I want the rest. All right, so you have to list out the rest, which is A, B, C, E, G. Can you see? All right, not super difficult, right? All right, and part 2, for example, they ask, hey, what is A intersect B prime? Whoa. All right, A intersect not B. Oh my goodness. Where is not B? Not B means outside B. Look, this is B. Look, this is B. This is B. Where is not B? Not B means everything outside